A woman standing on a cliff is watching a motorboat through a telescope as the boat approaches the shoreline directly below her. If the telescope is 250 feet above the water level, and if the boat is approaching at 20 feet per second, at what rate is the angle of the telescope changing when the boat is 250 feet from shore? And then we got 250 feet above the shore. We're trying to find angle theta, and we know that the boat is moving at 20 feet per second. We also know this is a right triangle because she is 250 feet from the boat on the shoreline. Okay, so now we need to find our general equation. Keep in mind the relationship is between x, y, and theta. So we know from Pythagorean theorem that tangent theta equals opposite over adjacent, which would equal x over y. Before we plug in anything, we want to figure out what we know. We know that the derivative of x with respect to t equals -20. We know that y equals 250, and angle theta equals pi over 4 because of the right triangle. What we're trying to figure out is the derivative of theta with respect to t. Okay, so now we have to differentiate the original equation, which is tangent theta over x over y. We know that tangent theta equals secant squared theta. That's its derivative. So we set up the equation as secant squared theta times the derivative of theta with respect to t equals 1 over y times derivative of x with respect to t. Then we're going to go ahead and we're going to plug in the information that we already know. The derivative of x with respect to t equals -20 and y equals 250. So we plugged it in down here. We got secant squared theta times derivative of theta over with respect to t, which equals 1 over 250 times -20. We also found out, since our equation is a right triangle, that 45 degrees equals pi over 4. We got that from the unit circle. So we plug in pi over 4. Secant squared pi over 4 equals 2. So we then multiplied each side of the equation by 1/2 in order to get the derivative of theta with respect to t by itself. We plugged it in, and we got the derivative of theta with respect to t equals -1 over 25, or 0.04. Alright, so our final answer is when the boat is 250 feet from the shore, the angle of the telescope is decreasing at a rate of 0.04 radians per second.